Hello everyone, welcome back to this channel. This is where we break down electrical engineering concepts into simple, powerful explanations. So, today we are tackling a question that confuses lots of people, and here it goes. Why does a single phase give us 230 volts, but a three-phase system gives 400 volts and not 690 volts? So stay tuned because by the end you'll understand the concept. You'll understand the secret geometry of electricity. Let's do a quick recap about the single phase. In a single phase supply, voltage is measured between the live or the phase wire and the neutral. And in most countries, it is standardized at about 230 volts, though some countries it's 220 or 240. Then a recap about the three-phase supply system is that in a three-phase system, we have three live conductors, i.e. we have the red, the yellow, and the blue, and each is carrying an alternating voltage wave. Each of these phases is 120 degrees apart. This is where you can say the red phase is 120 degrees from the blue phase, and the blue phase is 120 from the yellow phase. And each of these phases, just like single phase, has 230 relative to the neutral. So when you measure voltage at the neutral and the red phase, you get 230. Then you measure the yellow phase and the neutral, so you get 230. Then the blue phase and the neutral, you get 230. So the question is, if each phase is 230, why isn't the voltage between the two phases just a simple addition of 230 plus 230 giving us 460, or even 690 for the three phases? Let's talk of the secret behind this. The secret is all about the phase angle. Here is the trick. Voltages in the three-phase system are not in line with each other. They are separated by 120 degrees. So, when you measure between two phases, the voltage difference is given by a vector subtraction, not arithmetic. So here, it means that when we try to measure voltage between two phases, let's say red and blue, the voltage difference is not just a simple addition that you can just add 230 plus 230, then you get 460. It is as a result of vector subtraction, and it follows a formula which is the line voltage equals to the root 3 times phase voltage. Phase voltage is the voltage between the live and the neutral, or between one phase and the neutral, which in most countries it is 230. Then the root 3 approximates to 1.732, and so when we multiply, we get our voltage approximating about 400 volts. It may be less than that, approximating 390. So that's why line-to-line voltage in a three-phase system is 400 and not 690. You ask, why not 690 volts? In the three-phase, if the phases were in synchronism, let's say rising and falling together, then we would say yes, it would be 690. But first phase voltage would be 230 plus 230 equating to 460 or even more. But in reality, the 120 degree separation changes the math completely. That's why electrical engineers use phasor diagram instead of simple addition. The geometry of the sine waves explains everything. So let's talk of the real life applications. This difference between the 230 and 400 is super important in real life. In homes here we in homes you get 230 volts. That's single phase between the live and the neutral. Then in industries, motors and heavy machines run on 400 three phase. That's line to line supply, which is more efficient. Therefore, as we come to the end of our video, let's do a recap of what we've talked about. Let's wrap it up. In a single phase, it's 230 volts. That's measured live to neutral. Then in a three phase, it is 230 per phase. Let's say the red phase 230, yellow phase 230, then the blue phase 230. But if you have to measure line to line, let's say blue thread, it gives us around 400. Then yellow thread around 300. And not 690 because voltages are 120 degrees apart. Sorry. And it's not 690 because voltages are 120 degrees apart. It has a result of the vector math and not just a simple addition. So next time someone asks why three phase is 400 volts and not 690, you will know it's all about the root 3 factor. If this video has cleared up the mystery you've been having about the 230 and the 400, how it comes about, hit like, subscribe and ring the bell so you never miss more clear electrical explanation. And in the comment section, tell us, do you prefer working with a single phase or three phase systems and why? I'd love to hear your thoughts. Thank you for listening.